Hi friends, welcome to our channel Mallesham Creations. Mallesham Creations. Today topic is wet corrosion. As you have seen in the previous class that what is corrosion, how many types of corrosion is there. We have seen that corrosion is classified into two types. One is dry corrosion. It is also called as chemical corrosion. The second type of corrosion is wet corrosion. It is also known as electrochemical corrosion. Why it is called as electrochemical corrosion, I will try to explain. But before that, we should know what is wet corrosion. Attack of atmosphere on metal surface in presence of moisture is called as wet corrosion. Attack of atmosphere on metal surface in absence of moisture is known as dry corrosion. We have seen in the previous class. But now attack of atmosphere on the metal surface in presence of moisture is called as wet corrosion. We know that during corrosion formation, part of metal acts as anode and another part of metal acts as cathode. So anode and cathode is there, but in this type of corrosion, moisture is there. That moisture can act as conducting medium or electrolyte. Therefore, when anode, cathode and conducting medium or electrolyte is there, those three can combine each other and forms electrochemical cells. Therefore, this corrosion involves electrochemical cell pathway. In this anode, cathodes that are separated by a conducting medium, electrolyte, usually moisture. In the second step, at anode, metals undergoes oxidation. It is always common, usually. At anode, oxidation reaction takes place. In this type of corrosion, at anode, metals undergoes oxidation and forms metallic ions. For example, metal represented by M undergoes oxidation and forms Mn plus n number of electrons. The liberated n number of electrons move towards cathode. At cathode, usually acidic medium or water or oxygen is there in this type of corrosion that takes these liberated electrons and forms OH minus or O minus 2 as non-metallic ions. From this, it is clear that at anode metallic ions are formed, at cathode non-metallic ions are formed. The metallic ions and non-metallic ions combines each other and forms corrosion product. This corrosion product is formed in between anode and cathode in wet corrosion. Next, wet corrosion proceeds in two ways. That is, evaluation of hydrogen or absorption of oxygen. Evaluation of hydrogen and absorption of oxygen. What is evaluation of hydrogen? We will see. Evaluation of hydrogen type corrosion usually mainly occurs in acidic medium. Evaluation of hydrogen occurs in acidic medium. So in this type of corrosion, anodic areas are large and cathodic areas are small. In evaluation of hydrogen corrosion occurs in acidic medium, as well as in evaluation of corrosion, anodic areas are large and cathodic areas are small. Example for this type of corrosion is iron metal in contact with acidic medium. Iron metal is in contact with acidic medium. So we will see the mechanism in acidic medium. Just for example, this is the iron metal. This is the iron metal. Iron metal is in contact with acidic medium. This is the acidic medium. When iron metal is in contact with acidic medium, that undergoes evaluation of hydrogen pathway. Therefore, in this evaluation of hydrogen pathway, large anodic areas are there, small cathodic areas are there. Large anodic areas are there, small cathodic areas are there. We know that always at anode oxidation reaction takes place. This is about iron metal. Therefore, iron undergoes oxidation and converts into Fe+2+, 2 electrons. The liberated 2 electrons will move towards cathode. At cathode, H+, acidic solution is there. Therefore, acidic solution means H+ ions. That H+ ions takes these 2 electrons and produces hydrogen gas. This is the liberation of or evaluation of hydrogen gas. This can be represented in a reaction that at anode, iron undergoes Fe+2+, 2 electrons. The liberated electrons moves towards cathode and the reaction occurs at cathode is 2H++, 2 electrons gives H2 gas. So LHS and RHS, 2 electrons is common. Therefore, both electrons gets cancels. Overall, the net reaction is Fe+ plus 2H+ gives Fe+2+ hydrogen gas. This is the mechanism of evaluation of hydrogen in wet corrosion. The second one is absorption of oxygen. Absorption of oxygen. This type of corrosion takes place in basic or neutral medium in presence of oxygen. Absorption of oxygen corrosion occurs in presence of oxygen, and this occurs in basic medium or neutral medium. In absorption of oxygen type corrosion, usually anodic areas are small and cathodic areas are large. Why it is, I will try to explain. Whereas in evaluation of hydrogen, anodic areas are large and cathodic areas are small. But here in absorption of oxygen, it is reverse. In absorption of oxygen type corrosion, anodic areas are small, cathodic areas are large. Because here, example for this type of corrosion is iron metal in contact with neutral or basic medium. Neutral or basic medium. Usually in presence of oxygen, the surface of iron will form a iron oxide film. Okay, iron oxide film will be formed when iron is in contact with oxygen. That is usually known as rust. However, while forming iron oxide, usually known as metal oxide layer, sometimes maybe some cracks or gaps will be there. In that gap, the iron metal can act as anode. Maybe while formation of thin film, that is iron oxide layer, maybe some small cracks or breaks are there. The small crack or break can act as anode. Therefore, overall we can understand that in absorption of oxygen type corrosion, anodic areas are small, cathodic areas are large. In this mechanism, how we can see, this is, imagine iron metal. Iron metal is in contact with neutral aqueous solution, that is electrolytic solution. So in this, as we mentioned before, cathodic areas are large. This is cathodic area because when iron is in contact with oxygen or moisture, it forms a metal oxide layer or rust. Under that metal oxide layer, the metal can act as cathode. However, when in the metal oxide layer, some small cracks or breaks are there. Here we can see that crack or break can act as anodic area. Therefore, in this type of corrosion, large cathodic areas and small anodic areas are there. We know that at anode, oxidation reaction takes place. This is an example of iron. Therefore, iron gets oxidation, converts into Fe plus 2 electrons. The liberated 2 electrons will move towards cathode. At cathode, already oxygen and moisture is there. That oxygen and moisture takes these 2 electrons and forms 2 OH minus ions, hydroxide ions. This can be expressed in the reaction. At anode, Fe, iron, converts into Fe plus 2 electrons. At cathode, oxygen and moisture, water is there, that takes these 2 electrons and forms 2 hydroxide ions. However, at LHS and RHS, 2 electrons are common. Therefore, both the electrons gets cancels. Net reaction in this corrosion is Fe plus half O2 plus H2O gives Fe plus 2 plus 2OH minus. When Fe plus 2 and 2OH minus is there, it will readily form ferrous hydroxide, FeOH taken twice. When ferrous hydroxide is really not stable, it likes to convert into ferric hydroxide, which is a stable form, FeOH taken thrice. Therefore, it is readily reacts with oxygen and water and converts into ferric hydroxide, FeOH taken thrice. FeOH taken thrice is nothing but rust. So this is the absorption of oxygen type corrosion. Thanks for watching. Bye bye. Hi friends, welcome